Greetings, this is the first rehearsal of part 3. I'm skipping part 2 for now of my presentation this coming Saturday as I share the stage with James Tour and Rob Stadler and other fine scientists. So let me just get to it. Defining the fittest in fitness. Herbert Spencer and Charles Darwin described natural selection as survival of the fittest. Darwin claims that as the fittest survive through each generation, this leads to an increase in so much capability that so-called natural selection will construct organs of extreme perfection and complication. The flaw in Darwin's theory, however, is how modern Darwinist defines the fittest. And that flaw is fatal to Darwin's theory. Modern Darwinists confuse and equivocate their meaning of fitness with a common sense medical and engineering definition of fitness. They also redefine it and equivocate the meaning of adapted. Evolutionary fitness is a measure of copying efficiency for a given environment, i.e., how many copies can be made and how fast they can be made. Survival of the fittest is more accurately described as survival of the fastest reproducing copy machines, and not specifically whether the copy machine is made of organs of extreme perfection and complication. The more formal way to calculate fitness is illustrated in my peer-reviewed publication, Fisher's Fundamental Theorem of Natural Selection Isn't Fundamental After All. It's in an obscure ID-friendly journal. If you want first-rate stuff, go to Joe Felsenstein's Theoretical Evolutionary Genetics, if you really want a headache, by the way. So, again, think of evolutionary fitness as the measure of copying efficiency, not whether the species has complex designs such as the human brain. A set of nincompoops with 14 kids each are more evolutionarily fit than a set of brilliant individuals with only one kid each. So just kind of keep that in the back of your mind. Just emphasizing the point. The phrase to be or not to be, that is the question. The estimated time to copy that phrase by hand is 1 minute, whereas the King James Bible would take around 3 years by some estimates. By way of extension, by way of parallel, a bacterium is made of one cell. It takes it 20 minutes to reproduce itself, whereas the average time a human takes to make a copy or approximate copy of itself is around 20 years or 10,512,000 minutes. So just which is more evolutionary fit in the absolute sense, what you might call absolute fitness, bacteria or humans? So since it's faster to copy a small genome versus a large one, we would expect a Darwinian process to lead to smaller, not larger genomes. That would be the rule, not the exception. And so it was in 1965 in a experiment called Spiegelman's monster. Saul Spiegelman made an artificial creature, and after 74 generations, the original creature that had a genome of 4,500 DNA or RNA letters, ended up as a dwarf genome with only 218 letters. This should have been a big red flag for the Darwinists, but they just brushed it off. Now, granted, that was in an artificial environment, but it portended what we would find in natural environments. So now consider this lady. She's equipped for touring cold, remote environments without a lot of amenities. Whereas this lady is equipped for touring in urban environments with lots of amenities. So why carry around more than you need for a given environment? Now I'm going to extend this to the genomes of creatures. E. coli, there's this long-term evolution experiment run by Richard Lenski. And over the course of like 80,000 generations, it lost many genes. The generative AI will indicate this, and it says, well, it's considered beneficial, which is again double speak. It's considered increasing copy efficiency. See, beneficial as just this very precise and misleading term. It's really increasing copy efficiency. They can provide a fitness advantage by eliminating unnecessary metabolic pathways. Again, just dropping unnecessary baggage. So you can easily switch what equipment set you want to carry when you switch environments. But once a creature loses a gene when it switches environments, it can't get that gene back without gene transfer from another organism. So it's virtually a permanent change if it's not like a bacteria that can do horizontal gene transfer. So this long-term evolution experiment is an example of a Darwinian process causing self-destruction of genes to spread in the population. And Richard Lenski, he's an evolutionary propagandist. He's honest in recording, but really self-deluded in promoting. His experiment got one functional improvement. It's very trivial, as someone eventually demonstrated, although Lenski at the time thought it was a big deal. It's not. Whereas his bacterial lines lost many genes. And from one of our papers there, we show that there was a loss of many genes. For him to be celebrating his experiment with some great achievement, it's like a football team that's losing 200-0 in the fourth quarter with time running out, and then the losing team scores 2 points. I mean, is that any cause for a real celebration or claim of victory? That's why I say Lenski's delusional, but he's smiling. Well, I guess so. He still got paid despite the outcome of his experiments. And that's not an isolated case. Wolf and Koonin being the top evolutionary biologist on the planet, he and his co-author said, quantitatively, the evolution of genomes appears to be dominated by reduction and simplification, punctuated by episodes of unexplained complexification. And he cites a case where bacteria, parasites, other bacteria can lose up to 95% of their genes. And so there are many, they're starting to come out with more of these papers, evolution by gene loss. And here's one that's funny, 2023. It says gene loss is a key evolutionary force. That's because gene losses are pervasive, but then they conclude, well, that's a key evolutionary force. And I'm like, how can you build complexity by losing genes? That's just ridiculous. Here's another one, selection-driven gene loss in bacteria. Gene loss predictably drives evolutionary adaptation. This is a good paper by Michael Behe. Loss of function mutations is the first rule of adaptive evolution. So more examples. Intelligence and childlessness. This means that intelligent women, high IQ women, many of them are childless. Therefore, the not so smart women are more fit. They make more babies. Here's a New York Times best-selling book, Survival of the Sickest. So if we're not seeing, arrival of new fantastic capabilities, they have to appeal to getting sick as a means of increasing copying efficiency. And here's one that I chuckled at. This one talks about the evolutionary fitness, the advantage of premenstrual syndrome. So guys, listen up. If, according to the evolutionary evangelists, if you meet a girl who is not so smart, She has a variety of diseases and has really bad PMS. You may have a keeper there, guys. To make matters worse for Darwinists, it's not Lewontin, famous scientist, said it's not entirely clear what fitness is. So Darwinists, some of them are aware of the problem, but some have no clue. Here's Lewontin again. He wrote this great paper, The Confusions of Fitness, how it has problems conceptually. And I like the words he uses. He uses the word incommensurability. Incommensurability. And not only is fitness ill-defined, it's hard to measure. Andreas Wagner, evolutionary biologist, he says, an unassailable measurement of any organism's fitness does not in practice exist. And a author of a population genetic textbook says, fitness, they are impossible. Low levels of fitness, they are impossible to measure. And I just posed this question to generative AI. I said, why is evolutionary fitness an ill-defined concept? And generative AI responded, evolutionary fitness is considered an ill-defined concept because it is highly context dependent. Skipping ahead, evolutionary fitness is not an inherent property of an organism, but rather a measure of its reproductive success, i.e. copy efficiency. So first of all, don't be duped by all these claims that an experiment improved evolutionary fitness. So it's ill-defined. Increasing evolutionary fitness is mostly meaningless as far as the evolution of highly complex functions and new protein gene families. So since this won't work, and there are some people who are ID proponents and creationists, they are older creationists. So Stephen Meyer, who we mentioned earlier, he might be characterized as an old earth progressive creationist. He's certainly sympathetic to it. And the idea is the emergence of progressively more complex forms over billions of years is real, but not natural. It requires intelligent design and miracles along the way. There's a more dominant view of creationism, and that's young earth creationism, which I believe. And I say that assigning billions of years to the fossil record is a scientific mistake. Therefore, life was created, not evolved recently, and not over billions of years. This leads to the problem of why God would make similarity of creatures like chimps and humans. And I will say similarity between chimps and humans is due to common design by God, not common descent. We're very similar to chimps. Thank God for that, lest we have to do medical research on human fetuses. Praise God, we have some similarity to lab rats to test out and develop our new pharmaceuticals. So I never thought I'd be thanking God for creating rats and mice. So next time you see a mouse, praise God, he created mice for your welfare. Going back to an axiom, it's easier to break than to make. Just keep that in mind. That's why it's easier to lose genes than make them. Now let's look at complexity. We have what I call login password-like complexity and lock and key-like complexity. These are crude metaphors for two kinds of biological complexity. So let's look at login password-like complexity. So you have a login and you have a password. So the login is Richard Dawkins and the password is Darwin deserves a Darwin Award. So for the login, for the password to work, it has to when you enter it, it has to be spelled correctly. And that's what I call precision spelling. And in contrast to that, or by way of comparison, I have this idea of precision shaping. So you have lock and key complexity. A lock is complex, and you could sort of say a key is complex. It needs to have all those little dents and shapes. It has to be precisely shaped, and so that's not a trivial thing. So just think about precision spelling, precision shaping. Now passwords can have different levels of complexity. A high complexity password is one with many characters, such as this one that I just made up. Kepler's celestial mechanics, supercalifragilisticexpialidocious, anti-disestablishmentarianism. It's a long password. High complexity. Low complexity would be one with few characters, like A, B, C. So in biology, we have precision spelling of proteins, the amino acids in proteins. So proteins are made of amino acids, and there are 20 kinds, and they can be represented by English alphabetic letters. And I took the liberty to highlight the English alphabetic letter G in this collagen protein. And you could see a striking pattern here. Every third G in one part of the protein is three, every third one is a G. Every third amino acid is a G, a glycine. This is a very precise pattern. You see this precision spelling. Collagen won't work so well if you don't have that. Won't necessarily absolutely break it, but it'll be compromised. Similarly, this zinc finger human 136, it has a striking pattern again of precision spelling, particularly if you could see my cursor here, the C's and the H's. C's for cysteines, H for histidines, and that's where the zinc ion in each of these rows has to connect. It will not function unless the zinc ion connects, and it won't function if it doesn't have the right spelling. And this is a striking pattern of that precision spelling. There are examples of biology and precision spelling, and I just showed you some, but there are many more. No time to get into it. So now let's look at precision shaping. On the left is a square shape with a hole, a man-made nut, and on the right is a God-made object. It's sort of square with a hole in the middle, tiny one, but just how precise does it have to be? It has to be precise within less than 1 atomic radius of a potassium atom. And there are many examples of other examples of precision shaping in biology. That's a tongue twister, but no time to get into it. I'm just giving you just little tastes and hints of it. So we have these kids' toys. They are precision shaped. So all the parts, this 3D puzzle, all the parts of the 3D puzzle can fit. And on the right is the God-shaped, the God-made object for God's delight. And it also has precision shaping down to the angstrom level. So as I was pondering this in a paper that Dr. Sanford and I archived on ChemArchive, Biological and Medicinal Chemistry, I started to ponder all these things. And so in proteins, you have precision shaping and precision spelling. But what you can clearly see here is the spelling of one protein is radically, one family of proteins is radically different than another family of proteins. Also, the shapes of proteins are different. This began to hint to me that there are no transitionals, even as a matter of principle, as in conceptual, and I'll try to elaborate more on this, that can exist for major protein families. By way of analogy, to help understand this, consider the parts of a car. They're all shaped differently. It's very hard to evolve one part into another part. So just to illustrate this, explore this a little bit, evolving the design of a battery into the design of another battery it's reasonable. Incremental changes are reasonable. So we can conceptually, not necessarily physically, we can conceptually evolve the design of a 12-volt lead acid battery to another 12-volt lead acid battery with gradual incremental conceptual changes by altering the size of the parts and or the positioning of the terminals. Such transformations still result in a battery that makes electricity serving its primary function. So again, you can make these conceptual changes incrementally. Whereas, however, we can't even conceptually, much less physically, evolve a functional car engine piston into a functional car battery, or vice versa. And of course, the dog is saying, "Say what? You know, you can't attempt to do that if you're claiming that you can evolve one into the other." So it can't be done by small, gradual Darwinian transformations, where the intermediates, transitionals, serve a functional purpose for the car. And so likewise, we can't sensibly evolve a functional topoisomerase on the left into a functioning potassium ion channel by small, gradual Darwinian transformations, since the intermediates are unlikely to serve a functional purpose for the cell. So again, recall precision spelling and precision shaping. And I had a whole show on this on Real Science Radio, also on my channel. If you Google Aaron raw sewage flushed down the toilet, you'll see this elaborated more. So if you have any doubt that what I'm claiming is a bad idea, here is an honest to Darwin evolutionary biologist by the name of Dan Stern Cardinale. He's at Rutgers University. He's my friend, and when I first presented the idea to him in 2021, he said, I think that's right, Sal, that there's no common ancestor for all proteins. And over time, he became more and more emphatic about that. So let me play this clip. But first of all, let me make sure that my sound is shared so that you can hear this. Okay, let's play it.
On that, we agree. As you said, like we agree that proteins, unlike cellular life, do not share universal common ancestry, right? We disagree about cellular life, but we agree that proteins don't share universal common ancestry.
Proteins don't share universal common ancestry.
So now, Dr. Dan thinks, oh, that's not a problem for evolution, and a lot of the evolutionists will always say that. But how can you evolve this? Random mutation can't evolve something as complex as some of these proteins. And I already showed you natural selection can't. So what do you have? It's like, well, nothing. Now, Dr. Dan will retort and say, well, new proteins emerge all the time. Let's even grant that many new proteins emerge all the time. The problem is complex ones don't spontaneously emerge in any experiment we have, and there's no reason we should expect them to, except if you believe in evolutionary biology. But there's nothing from first principles of physics and chemistry that we should expect this. And I already pointed out natural selection doesn't work to do this. It would be the exception and not the rule, at the very least. So a creature can't evolve if it is dead. Darwinian processes can't make sufficiently complex proteins. So when I interact with Darwinists, they say stuff. So let's just take a generic Darwinist. He'll say natural selection selects for topoisomerase because those creatures that have topoisomerase are alive, and those that don't, and those creatures that don't have topoisomerase die. Therefore, natural selection favors topoisomerase. Therefore, natural selection selected for it and thus evolved it. See? That's easy. My response is the process of keeping something that already works is not the same as creating something that will eventually work. You're equivocating, that is, changing the meaning of the phrase select for, and thus falsely equating the idea of keeping something that already exists with the same idea as creating something that will eventually work. Keeping is not the same thing as creating. So this selecting for, are you talking about selecting to keep or selecting to create? They're not the same thing. Also, a creature can't create anything if it's dead. Thus, it can't evolve life-critical proteins or anything else life-critical. To illustrate this, I'm going to cover topoisomerase. I had published a paper, co-authored a paper in Oxford University Press on topoisomerases, by the way. And on the left is the spelling of topoisomerase. On the right is the shaping of it. So again, precision spelling and precision shaping. By the way, this is a complex protein, 1,531 amino acid letters. Compare that to supercalifragilisticexpialidocious, which is only 35. So try entering that. If you had a password like that, that'd be pretty tough to enter and get all the characters right. So I encourage you to look up topoisomerase on the Discovery Institute website. Just Google around, type topoisomerase, Discovery Institute. Joe DeWeese, he did a video on this, and this has been his lifelong research interest, is the topoisomerase enzyme right there. He and I published in the Creation Research Quarterly. That's also peer-reviewed. But the big deal is Joe DeWeese published in a peer-reviewed journal in Nature, the prestigious scientific journal Nature. He and I published on topoisomerases in the Federation of American Societies for Experimental Biology, twice on topoisomerases, and then in Oxford. All this to say, we have some familiarity with topoisomerase, and this is the problem we saw. So on the left, you could see a man-made pair of scissors. On the right is the God-made pair of scissors known as topoisomerase. So why is it a pair of scissors? Well, topoisomerase, in order to untangle the DNA, it has to untangle the DNA, otherwise you die. So the DNA will get tangled, and it needs a mechanism to untangle it. And so the way to do that is to cut it, do an untangling move, which is kind of illustrated there. You'd have to see the video to see this. So cut it, untangle it, and then reconnect where you cut it. Now think about this. If you have something that is a prospective evolving topoisomerase, the reason it won't evolve is the creature would be dead. Because if this prospective topoisomerase cuts but doesn't reconnect, it fails to untangle, the creature's dead. Likewise, if it cuts but doesn't untangle, creature's dead. If it had the capacity to reconnect but it can't cut, the creature's dead. If it could reconnect but it can't untangle, creature's dead. If it could untangle but can't reconnect, creature's dead. Could untangle but can't cut, creature's dead. In other words, it's not going to evolve because dead things don't evolve. And so Darwinists have no answers, but they insist you believe in evolution by natural selection. And if you have to believe something without evidence, or in the total absence of evidence, we call that faith. And so what can I say? What can I say? If it's faith, then it's a religion. So I say to my creationist and intelligent design colleagues, don't argue whether intelligent design is science. Argue whether Darwinism is religion. And there was this atheist that kind of realized that, Michael Ruth. He wrote the book Darwinism as Religion in Oxford University Press. So, it was obvious to him that Darwinism is a religion. So how much more to any of us? So don't, I would just say, don't teach religion of Darwinism in public schools. And so that's my dress run. I had some mistakes I need to correct and clean up my slides, but I just figured I'd release it. And feel free to comment and give some feedback. And thank you for watching. Take care and God bless you. Bye-bye.